how can an AI that suddenly mastered language suddenly solve a fiendishly difficult math problem? It feels like a contradiction. Language is flexible, poetic, full of nuance. Math demands absolute, rigid precision. The answer isn't that large language models, or LLMs, secretly learned how to be calculators. It's that they learned how to use them. At its core, an LLM is a statistical prediction machine. After being trained on a staggering amount of text, books, articles, essentially the internet, it doesn't know anything in the human sense. Instead, it predicts the most likely next word in a sequence. It generates text one piece at a time, based on statistical patterns. This is brilliant for writing an email, but a disaster for arithmetic. For an LLM, the number 12,345 isn't a single value. It might be broken into fragments like 12 and 345. This internal representation inherently sabotages its ability to perform precise calculations. It's like trying to do long division after someone has randomly chopped your numbers in half. So how do they overcome this? The first breakthrough was a simple instruction: think step by step. This technique, called chain of thought, forces the model to show its work. It mimics human problem solving, breaking down a complex problem into a sequence of smaller logical steps. This doesn't magically give it a math brain, but it makes the reasoning process more transparent and less prone to a single catastrophic error. But the real secret, the most powerful technique, is tool use. LLMs are not solving the math, they are translating it. When you give a model a complex word problem, it does what it does best. It understands language. It parses the question, identifies the variables, and figures out the necessary operations. Then, instead of trying to compute the answer itself, it writes a small piece of code, a Python script for instance, or it formulates a query for a specialized tool, like a symbolic math engine. Think of it this way. Wolfram Alpha is like a traditional calculator on steroids. It's built on fixed rules and pure logic. It is deterministic. It doesn't guess. It computes. An LLM, on the other hand, is the brilliant translator who can listen to your problem in plain English and then communicate it perfectly to that specialist engine. The LLM understands the what and the why. The symbolic engine handles the how. The LLM then takes the precise answer from the tool and translates it back into a conversational, human-readable explanation. This explains why they still struggle with truly novel mathematical problems, the kind that require inventing a new technique not found in their training data. They can't reason from first principles. They are masters of pattern recognition, not genuine mathematical discovery. What we're seeing isn't an AI that has become a mathematician, but something far more interesting: a bridge. It's the birth of a hybrid intelligence, where the intuitive, language-based pattern matching of a neural network collaborates with the cold, hard logic of a symbolic calculator. It's a partnership that points to a future where human creativity is amplified, not replaced by machines that have finally learned to speak both our language and the language of numbers.